Hello and welcome everybody to my session about Prisma 2 that's titled Confidence and Productivity for Your Database. Let's jump right in. So my name is Nikolas Burk. I'm based in Berlin and I lead the developer success team here at Prisma. And you can follow me on Twitter and on GitHub as @NikolasBurk. The agenda and the things that I want to talk about today are 3 points in particular. The first is an introduction where I'm going to talk about the broad problem that Prisma is trying to solve and then how we want to solve it. In the second section of the talk, I'll talk a little bit about what Prisma 2 actually is and how it works. And then the meat of this talk is going to be a live demo where I'm going to show you how to get started with Prisma 2 pretty much from scratch and build a REST API and a GraphQL API, and all of that in the next 25 minutes. So buckle up for this talk. And let's start with the introduction and the problem statement, that is that working with databases in Node.js can be really difficult. And to understand the kind of options that you have as a developer when you're working with a database in Node.js, I've prepared this slide here. There are basically 3 categories of tools that you can choose from. And the first category is that you can send plain SQL strings to your database with just some relational database driver, basically. And then you're constructing your database queries as strings and you're sending them over to the database. And that's really the lowest level of abstraction. And that can get a little bit tedious and cumbersome to work with these SQL strings and code. You get no type safety and almost no help from your editor when you're taking this approach. The second option then is SQL query builders. And these are libraries that let you compose your SQL queries programmatically. So they give you a programmatic they give you a programmatic API to construct your SQL queries and then send them over to the database. So you are already climbing up a little bit the abstraction ladder, but you're still on a very low level because you're still writing SQL ultimately. And then you have the third category of tools, and these are called object relational mappers. And these tools, they work in a way that you define your tables, the tables that you have in your database, as classes in the programming language that you're using. And there is a problem with this approach that's called the object relational impedance mismatch. And that's just a fundamental mismatch of the way how data is represented in relational databases and object-oriented languages. But this talk today is not really about these 3 different categories of tools. In fact, if you want to learn more about those, I would recommend to check out this talk by my blog post by my colleague Justin, who wrote about these 3 different approaches and the trade-offs that come with them. So the solution to this problem is that Prisma makes working with databases easy. And we'll learn in this talk how exactly that works. So the second section is about Prisma 2 itself. Let's dive right in and understand what Prisma 2 even is. But I want to start this section with a short preface because there is a lot of confusion about the differences between Prisma 1 and Prisma 2. And at this point, if you've heard anything about Prisma 1 in the past, I really want you to forget everything that you knew about Prisma before and start looking at Prisma 2 with a completely fresh mind. So I think we can do that now. All right, that should have worked. Everybody forgot everything they knew about Prisma 1 and are fresh to talk about Prisma 2. Prisma 2 is an open source database toolkit that mainly consists of 3 tools. We have Prisma Client, that's there for database access, Prisma Migrate, and Prisma Studio. Prisma Client is the tool that we've just launched for general availability. So this is actually not accurate anymore. This should say general availability here, not in beta. But Prisma Migrate and Prisma Studio, the 2 other tools that we have available in the Prisma database toolkit, they are currently still in an experimental state. The core goals of Prisma really are to boost productivity and increase confidence of application developers that are working with databases. And that's mostly because the approaches that I've shown on a couple of slides before, they feel a little bit less productive oftentimes for developers, or developers aren't quite sure that they're doing the right thing when they're using Prisma. So the big question is, how can Prisma increase confidence and boost developer productivity at the same time? So let's look at a couple of things that contributes to this. Prisma boosts productivity and increases confidence by letting developers think in objects instead of SQL. And that's a big benefit of Prisma, that you don't have to perform this cognitive and this practical mapping of relational data to object-oriented data, but rather you can actually go and just think of your data in the way that you're used to anyway, as objects. Prisma also lets you work very intuitively with relations. And in my demo, we'll actually see what exactly that means. It means that you don't have to follow the model of relational databases with foreign keys when you're working with Prisma Client and perform joins to manifest relationships across entities in your application. But instead, you can just think about them a lot more intuitively in the way that you're used to in your programming language anyways. And then you also get auto-completion and type safety for all of your database queries, which really is a big benefit. Then there is a declarative and human-readable database schema, and that's a big benefit if you're used to reading SQL table definitions, which can feel very noisy at times. And the Prisma schema that Prisma introduces is basically a declarative version of what your database schema actually looks like, and it's human-readable so that you can check it into version control and everybody understands what your data structures actually look like. And this Prisma schema is also the single source of truth for your database and application models. In traditional database tools, you often have the problem that you need to synchronize the changes between your database and your application models. And with Prisma, that synchronization happens automatically by generating a client, a database client from the Prisma schema. All right, so let's jump into the live demo where I'm going to show you how you can get started with an existing Postgres database and introspect it with the Prisma CLI. Then we'll generate Prisma Client, which is this type-safe query builder that lets you send queries to your database. Then we'll explore some of the queries in a demo script, just a simple TypeScript script, really. And then I'll show you how you can get started to implement a REST API and a GraphQL API. And all of that is going to happen in the same application, in the same project that I'll be using for this demo. So let's jump right into the demo right now. So I'm starting here with a Postgres database that you can see on the right, and we have 3 tables here. So we have the post table, the profile table, and the user table, and there is a relation from user to post and user to profile. So here I have my project, my TypeScript project, which is really just very bare bones at this point. I don't have a lot of dependencies except for the required TypeScript dependencies. And the first thing that I'm going to do is I'm going to add the Prisma CLI as a development dependency to my project so that I can use it to introspect my database and generate my Prisma schema. But before that, I first want to create my Prisma setup using the Prisma init command right here. And what that does, it creates this Prisma folder on the left with my empty Prisma schema and a .env file to set my database connection URL, where I'm now going to input the credentials of my local Postgres database that I'm using. Next, I'm going to run the Prisma introspect command and see that 3 models have been written into schema.prisma. So let's see what actually happened here. And indeed, we can see that this Prisma schema that was just empty actually now has 3 models inside of it: post, profile, and users. And these 3 models, they mirror the table definitions that you previously saw in Postico. And one thing to note about this Prisma schema is that whatever you see here will determine the names of some of the queries in your Prisma Client API. And to make these queries a little bit more idiomatic, I'm going to change a couple of the fields here to ensure that they feel more idiomatic in the Prisma Client API when I want to send queries to the database. So with these adjustments, I can go ahead and add the Prisma Client dependency to my project. And now that I have that available, I can use that inside my empty TypeScript script right here and import Prisma Client from the package that was just installed. Then I'm going to instantiate it. And now I'm going to use this Prisma Client instance in a function where I'm going to send database queries. But in fact, because I don't want to write all of this, the boilerplate for this function, I prepared it right here as a snippet. So here we go. We've got the import, we've got the instance of Prisma Client, and we have a function, a main function that is being called down here. So let's go ahead and formulate our first query with Prisma Client. The way that it works is I can just use the auto-completion here in my editor to figure out the queries that I have available. And we see that I have one property here on this Prisma Client per model. In this case, I just want to go ahead and retrieve all the posts from the database that I have currently stored. So I'm using the console dir here for logging so that later on we can also print nested objects. And I'm sending the query to the database. So let's observe the output. We see that there are 3 posts currently in the database, and they are all returned right here. And one thing that I noted on the slides before, a bigger benefit of Prisma Client is that it lets you work very intuitively with relations so that you don't have to perform any joins across your tables manually, but instead you can use the Prisma Client API to do so for you. And the way how that works is actually that you can use the include property here on find many, and then you just say you specify the relation that you also want to retrieve right here. So if I send this query again, we'll now actually see that each post object comes with a nested object on the author field. And I can go even further on this one. I can say that because an author has a profile, again, I can include that profile in the query response. And if I run the query again, we see that we get the author, but again, another nested object, and that's the profile for this one. So that's very nice. But what's even nicer, especially when using TypeScript, is that I get full type safety for all the results of Prisma Client. So as you can see here already, the posts result here, the result of the query is statically typed. And this works even to a level that you probably haven't seen before when it comes to database tools. So here I'm going to do a little experiment where I want to print the bio of the author of a certain post. So I can just traverse the relationship like this here, post.author.profile.bio, and I can go ahead and print just this. But the type safety aspect of this is actually here when I can go ahead and say that I want to select just the ID, for example, of the profile so that the bio isn't included in the query result. And we see that immediately the red squiggly lines appear in VS Code telling me that the property bio does not exist on the type that is generated for profile at the moment. I can include it like this again, and the error is gone. I can run the query again, and everything works. All right, so now that you understand roughly how Prisma Client queries work, I want to show you how you can use it to build a little Express application. So I'm going to add Express as a dependency. And because I'm using TypeScript, of course, I also want to add the types that come along with Express. And again, I prepared a rough boilerplate for a very traditional Express application where we're just importing Express and we're setting it up to properly configure the responses. And now I can go ahead and implement my first route. And this route is going to be a very simple route that is returning all of the posts in my database. So again, just the typical Express boilerplate right here that you have when you're implementing a route. And the approach that I'm now taking actually looks very, very similar to what you just saw in the script. I'm just asking for all the posts in my database and return them using the rest.json function that's provided by Express. So now that I have this code implemented and this route implemented, I want to go ahead and test it. And the way how I'm doing that is by using a REST client right here in my editor. And this is the request that I'm sending. So just a GET request to the route that is specified that I implemented. So I'm going to send the request, and the response data we can see here on the right. So this route works. That's great. But what if I want to go ahead and actually write data to the database? For that, in a REST API, you typically use a post request. I'm going to make that to the same route here and implement it with the same kind of boilerplate. And this time, I'm going to use the create function of Prisma Client that's provided. And again, I'll be guided by the autocompletion for whatever I need to provide. So I need to provide the title. And that's a good point because I need to first extract the parameters that are sent in the post request from the request object that's coming in. And now I'll be able to just provide all of the data like this. And I'm returning, of course, the new post that I just created. So this assumes that people send over the title, the content, and the author email in the body of the post request. So let's go ahead and restart our server. And then also go back to our HTTP request that I have prepared and send this HTTP request to the API. And let's see if that works. All right, so we now created this new post called with the title Hello World in the database. Let's just send the GET request again just to make sure everything worked. And we see that we now have this Hello World post in the database. So that's great. As the next thing and the last thing in this demo, I want to show you how you can now build a GraphQL API instead of a REST API in the same project. And for that, again, I'm going to delete pretty much all of the code. To be a good citizen, I'm also going to remove the dependencies that I added before and just add the only dependency that I need for this, and that's the Nexus dependency for the Nexus framework. While this is installing, I'm already going to import the schema object from Nexus, which is my main object that's used to configure the GraphQL API that I want to build. And the way how that works is that you use the schema.objectType function that's provided by Nexus. There you go. And you can define your GraphQL types like this. So the GraphQL types that I'm defining now are going to mirror the type definitions of my Prisma schema. So for this, I'm actually going to put them side by side. And for now, I'm just going to remodel the user and the post, but not the profile. So let's go ahead and add the ID, name, and email fields. ID is an int, and that's defined like this. Then we have a string, that's the name. And then we have another string, that's the email of the user. And let's do the same for post. It has a title, it has content, and then it has a Boolean field that's called published. with all of these different types in place, I can actually already go ahead and start my Nexus server. And the way how that works is using the Nexus dev command that I'm just using as my dev script right now. So here we go. I'm starting the Nexus server. And I can already see that there is a GraphQL server listening at this URL right here. Here comes the GraphQL server. So what does the GraphQL API look like at this point? Well, we already have the user and the post types as we defined right here, so that worked. But the only thing that's not quite right yet is actually the nullability of a few of these fields, because right now all of them are nullable, but that's not what's specified in the Prisma schema. In the Prisma schema, only the fields that are suffixed with a question mark are nullable, but all the other fields are required. So in order to make that right, I need to configure this in Nexus right here. And here's how that works. I just add this option to the fields that are required. And I save my file. And now we see in the playground that the fields that I marked as required indeed are now also required in the GraphQL API. So that's nice, but of course, an API isn't really interesting when you don't have any operations. So I'm going to now add a query that, similar to the REST API that you've seen before, will just return all the post objects that are currently stored in the database. And I'm using the Nexus API for this again. I'm building up a new query that's called posts. And they have the type post. And it resolves simply by returning all the posts of the database. So let's go ahead and test this query in the playground. And it works. We get the same queries, the same post records displayed that we saw before. So let's also go ahead and implement the mutation, a mutation to create a new post. T.field, create post. And this one should still return a post. And notice how I'm getting auto-completion even for the types that I have here in my GraphQL schema. This takes 3 arguments. The title, it's required. The content, which is not required. And the author email that is required. Oops. All right, now we need to implement the resolver for this one. And this time we are again using the same Prisma Client instance, prisma.post.create with everything that you knew before. We've got the data, and that includes the title. We retrieve the args from the title, and notice how even the arguments that I just defined in the line above are statically typed. And I'm doing the same dance to connect the author with the email that's provided. And let's go ahead. I saved the file, so the new mutation should show up. And let's go ahead and test this. Hello world. Content, I'll leave that on empty, and the author mail is alice@prisma.io. We need to make sure that we're using one that already exists in the database. So I'm creating the new post. Let's go back and retrieve that, and we see that we get this new post here in the database. All right, so this is how you can implement your GraphQL queries and mutations with Nexus and Prisma. If you want to save some boilerplate, I could now show you how you can add the Nexus plugin Prisma to the mix here, and then even get rid of the implementation of these kinds of resolvers of the boilerplate that you need here. And like that's what you can do. You can get rid of the boilerplate that you still need to write for these operations here by leveraging information from the GraphQL schema. I'm going to go back to my presentation. That's it for this talk, and thank you all for attending.
Nico, thank you so much for that talk. It was really interesting to look at Prisma through the lens of like productivity and confidence.
Yeah, sure, sure. I really enjoyed the talk.
We're going to do a Q&A now. Are you ready to take some questions?
For sure. Let's give it up. Okay,
so before we start, just a quick reminder that you can ask questions via the Slack channel, Prisma Day. If you haven't joined already, it's slack.prisma.io. You'll be able to join. So let's get started. We have one of the very first questions that was asked was, how would you recommend deploying an API using Prisma? Docker, serverless, node server, any other options?
So that really comes up to like what you want and how you want to deploy. So Prisma Client is flexible to be deployed in all of these deployment scenarios. You can deploy it in serverless environments, for example, with AWS Lambda, but you can also deploy it to a more traditional, like long-running node server. And in fact, like that's what we've a lot of seen people do like very successfully. And that's probably what I would recommend. But it is certainly possible to use the deployment scenario of your choice. And in fact, we also have a number of deployment guides in our documentation. So if you're curious how you deploy things, for example, to AWS Lambda, then be sure to check out our docs and follow the deployment guide there.
Cool. Now, a really important question here is, which editor theme do you use in VS Code?
I believe it's called Solarized Light or like Solarized Sunlight, something like this. It's my preferred version. I'm not that much of a dark mode person, so I really like my light mode, and especially for presentations, I think it's also always helpful to not have the dark background and have a better contrast. So yeah, I'm a light mode person, and that's Solarized Light, I think.
Cool. And I mean, we saw in your talk a lot of really nice auto completion features. Do they also work if you don't use TypeScript? For example, if you're just using plain old JavaScript?
Yes, absolutely. So you can use Prisma Client just with plain JavaScript, and there is not really a difference in terms of how you would use it. So the script that I showed and like the REST API and the GraphQL API that I showed in my talk, they were all using TypeScript. But you could equally well just remove pretty much the tsconfig file from that project, remove the TypeScript dependencies, and then just turn these .ts files into .js files, and then run it with the node command. So it really isn't a big, like in the way how you set it up, you don't have to do a lot of effort in order to get TypeScript to work, and then TypeScript has additional benefits, like even more so than just auto-completion that you also get already if you're using plain JavaScript. But with TypeScript, of course, you get the type safety that when you have a typo somewhere, or like the way I showed how you can retrieve partial objects or include relations in your Prisma Client queries, that the results are completely typed. These kinds of benefits you'll only get with TypeScript. But if you're using plain Node, you'll certainly benefit from the auto-completion as well.
Right, yeah. Is this supported in other code editors besides VS Code? Do you have much experience with that?
I'm actually not 100% sure, but to be honest, I would expect that this is supported in most code editors. And the reason for that is that when we install the Prisma Client like node module in your node modules folder, then we include the index.t d.ts file. So the type definitions are included in the node module. And typically code editors are capable of picking this up and then like being smart enough to show you the auto completion options like from these types. So I would expect that works also in other editors.
Cool. And a question that was that came up was, how does Prisma compare to Hasura?
That's a really good question, and a question that we hear a lot, actually. So I'm happy about the opportunity to clarify that a little bit. I talked about Prisma 1 and that you should forget everything that you knew about Prisma 1 because that was focused on GraphQL. And that's exactly also kind of the response to that comparison with Hasura, where like Prisma 1 and Hasura were kind of similar because both gave you the GraphQL for your database. Prisma 2 is actually very different. It's very different from Prisma 1, and it's also very different from what Hasura offers because Prisma 2 has no native association with GraphQL anymore, right? There is no GraphQL layer inside of Prisma 2. It's really just a library for you to access your database and in the future to like migrate your database. So it's really just like really an NPM library that you install inside of your project. And it's not some standalone server anymore that you need to deploy or that gives you a GraphQL API. It's really just on the same level as a SQL query builder or an object relational mapper. And these kinds of tools are also very different from what Hasura offers.
Mm-hmm. And if you were to develop an API today for a greenfield project, and by greenfield, I mean a new project that's being started from scratch, what kind of API would you use for that? Would you go down the REST path or down the GraphQL path these days?
I am a little bit biased just because I'm a huge fan of type safety. I like strongly typed schemas that tell me exactly what kind of queries I can send to an API and what kind of data I can expect in return. And the only way for me to get that with today's technologies is GraphQL. So for me, it would always be a no-brainer to kind of go with GraphQL, but in the end, it's always a question of kind of your use case and the things that you're building. If you're a small team with 1 or 2 people and you communicate every day about what you're building, then I think you might not need those benefits. But even then, I think it would be still beneficial to use GraphQL.
Right. And we have also a question from Pascal. You inferred the relations for the existing database, but what about the indices? Will I still have to touch the database for those? Can you comment on that, Nico?
I'm not 100% sure how exactly that's meant, but with like indices in general, like you currently can't, or like you can configure them also in your like in your Prisma schema. But the way how that typically works is that you would probably configure it with SQL in your database and then introspect your database to have them in your schema.
Cool. Well, Nico, thank you so much for your talk. It's been really great. And have a nice day.
Thank you, Daniel.